In this lesson, we will discuss Mathematics of Finance, chapter number 5th. And today our topic is compound interest. As I have told you that there are two ways to calculate interest. First is the simple interest, which is interest is to be calculated on principal amount only. While compound interest, which is our topic, interest is to be calculated on principal plus interest amount or interest on interest. Now, what is the meaning of interest on interest or compound interest? I will show you with the help of example, as well as we will also derive a formula for the compound interest. Suppose the compound interest is represented by C, and suppose you have $1,000 and you want to invest in a bank, and the manager says that he will give you 6% interest compounded annually. Compounded means interest on interest, right? So this is your investment, initial investment, and he says that he will give you 6%, right? So 0.06 you will get, and you have invested your amount for 3 years. So for first year, this is your original amount and this is the interest. If I will take 1000 common, right, because 1000 is here and here, so whatever is left, 1 plus 0.06, and if you will calculate 1 plus 0.06, it will be 1.06 multiplied by 1000. You will have $1,060 at the end of the first year. So see, in this 1060, your principal amount, which was 1000, and your interest, which is $60, both are included. So see here, interest is to be calculated on the principal, which is 1000 in our example, plus interest, which is $60 in our example. So total is $1060. You will get interest on this amount in next year, second year. So second year, so that is why it is called interest on interest. We are not using for the second year the whatever was the original investment. We are using our investment plus the interest, which is $60. So you will get interest 6% on this amount, on principal plus interest amount. So again, if I will take 1060 as a common, here I am going to use the number to show you. When we will derive the formula, I will only use the symbol PIN, right? Whatever initial investment interest, I will show you. If I will take 1060 common, so here we have 1 left and here we have 0.06 left. So add 1 plus this, multiply by 1060, so you will have $1,123.60 at the end of the second year. So for the third year, you will get 6% on this amount. In this amount, our original amount, our initial or principal amount, and the interest of the last 2 years is included. So 1123 plus 1123.60, this time you will get interest 6% on this. If I will take 1123.60 common, because we have here and here as well, so here we have 1 left, 1.06. It will be again 1.06 multiplied by this, then you will have $1,191.02 at the end of the third year. To obtain a formula for the accumulated value Cn, so see, if suppose we have n number of periods, this is for first period, second, third, we have L. So we will represent Cn, right? To obtain a formula for the accumulated value Cn after n interest periods, we recognize C1, C2 and C3 in the form that suggests the pattern. So for Cn, we have to prove this one now, right? Or we have to derive this formula. How we will write down in order to find out the compound interest. Okay, so start from C1 again, 1000, 1 plus 0.06. So see here, same thing. This one, 1000 into 1 plus 0.06. For second year, 1000, 1 plus 0.06. When you will calculate it, the answer should be 1060. And you will get 1 plus 0.06. Okay, I will explain to you what I did here. This one was your original investment and you are getting 6% interest. And we have proved this here, this one. And second is this one. So we can write down C2 like this as well. This one is your initial investment plus the interested amount. If you will calculate this, it should be equal to this. But we are deriving the formula, that is why I am writing in this way. Same thing here, this is 1060 and you are getting 6% on this amount. So if see here 1000 into 1.06 is here and same is here, if I will take common 1001 plus 0.06, so what is left here? Here we have 1 plus, and this one I have taken as a common, only this thing is remaining, 0.06. So for the second year, see both are same, it means we can write down square. And again, if you will calculate it, it should be equal to 1123.60. And for the C3, now we have this much in the back, this our initial plus our interest amount. And we will get 6% on this amount. So plus 1000, 1 plus 0.06 whole square into 0.06. See, same 1000 into 1 plus 0.06 square is here and here. We will take as a common. So whatever left here, 1 plus here 0.06. So, or we can write down 1001 plus 0.06 whole cube. So this is for the first year. We can write down like this. This is for the second year. This is for the third year or third period, you can say. Right? This certainly suggests that for what about Cn? If we have Cn, C4, C5, Cx up to Cn. So Cn equal to 1001 plus 0.06 raised to power n. If we have n periods, so see, same thing you have to do. For C3, for third period, it is 1000 because we have invested 1000 and this is the interest rate cube. So Cn is equal to 1000 into 1 plus 0.06 raised to power n if we have a n number of periods. Now we have to derive the formula for the compound interest. We now extend this result to derive a formula for the cumulated value of Cn of an initial investment of $P, right? $P. We will represent initial investment with P. I is the interest rate, right? N is the number of periods and M times per year. How many times in a year? After the first interest rate. Okay, so from C1 we will write down P plus P into I divided by 100 into M. Okay, I will show you from here. As I have told you that these are the symbols and here I have used the numbers. So same thing, this is our initial investment. We will write down P plus P again, and this is the interest rate, whatever is the interest rate, I, right, and divided by M. And we have discussed M in the last lesson. I will explain to you when we will solve the question. I will again give you the example what we have to write down here, and then raised to power n. So same thing we are doing here, P plus P into I in divided by 100 into M. This is for the first year. After the second period, C2, right? Okay, one more step I can write. This implies that if I take P as a common, so here we have 1 plus I divided by 100M. So for P2, now, so C2, we have this much amount now. P into 1 plus I divided by 100 into M plus P, we will get interest on this amount. Here I am using the symbol instead of the figures. In the last slide I was using the numbers here. So same thing is here. Now we will get the interest on this amount. So if I take P into 1 plus I divided by 100M as common, so here I have only 1 left, 1 plus I divided by 100 into M, which implies that P into 1 plus I divided by 100M whole square. Same thing here we did, this one. Here I was using the number, right? Here I am just, because we are deriving the formula. And for C3, similarly for C3, P into 1 plus divided I divided by 100 into M whole square, and now we will get interest on this amount into I divided by 100 into M. If I will take P into 1 plus I divided by 100M whole square as common, here we have 1 left plus I divided by 100 into M, which is equal to P into 1 plus I divided by 100M whole cube. This is for the third period. Similarly, if we have n periods, right, Cn is equal to P into 1 plus I divided by 100 into M whole raised to power n. This formula we have to use in rest of the exercise to solve the questions of compound interest. If we have n periods, so Cn is equal to P is our initial amount into 1 plus I divided by 100 into M whole raised to power n. Now suppose by using this formula, I will show you quickly one example. Suppose you have 10,000 and you want to invest, and the manager says that he will give you 6% compounded monthly after 2 years or 24 interest period, right? So this represent number of period. Here we have 24 periods because he says compounded monthly, and you have 2 years. In 2 years we have 24 months. So C24 is equal to 10,000 you are going to invest. 1 plus I is the 6%, and then 100 is there. What about M? See, there are how many months in a year? There are 12 months, so we will write down 12 here. N, whole raised to power total number of periods. So there are 2 years, but it says compounded monthly, so you have to convert in months. There are 24 months. So 10,000 1 plus 6 divided by 1200 whole raised to power 24. If you know how to take the LCM, you can take the LCM, or you can do 6 divided by 1200, whatever, add 1 and then raised to power 24. When you will simplify it, the answer should be 11,271.60. So your amount will be after 2 years or after 24 months compounded annually at the interest rate of 6%, your amount will be 11,271.60. So practice this problem. If any point is not clear, you can ask me. Subscribe to my channel, and thanks for watching.